Welcome to ZoomInData. Hello everyone. Thank you for joining the fourth video in our comprehensive Azure Logic Apps series. In this session, titled Understanding Triggers, Polling versus Webhook Types, we will explore the two primary trigger patterns in Azure Logic Apps, polling and webhook. Detailed differences between polling and webhook triggers, including how each works, performance implications, and use case suitability. Common examples of built-in and managed triggers in both categories. Mastering these trigger types is critical for designing efficient, low latency, and cost-effective workflows. If you find this content valuable, please subscribe to ZoomInData and enable notifications to follow the complete series. What are the two main types of triggers in Azure Logic Apps? Triggers in Azure Logic Apps are classified into polling triggers and webhook, push, triggers. Polling triggers actively check for changes at regular intervals. Webhook triggers passively wait for events to be pushed to them in real time. Define a polling trigger and how it operates. A polling trigger periodically queries an endpoint or service according to a specified schedule to detect new data or events. It checks for conditions like new files, emails, or messages every few minutes or seconds. When new data meets the criteria, the trigger fires and starts the workflow. Define a webhook trigger and how it operates. A webhook trigger, also called push trigger, registers a callback URL with the source service and waits passively for notifications. The service pushes events directly to the callback URL when they occur. This enables real-time, event-driven activation without constant checking. What are the key differences between polling and webhook triggers? Polling triggers consume resources continuously due to repeated checks, even when no events occur. Webhook triggers are more efficient as they only activate on actual events, reducing unnecessary executions. Polling offers simpler setup but higher latency and cost. Webhook provides lower latency and better scalability. When should you choose a polling trigger? Use polling triggers when the source service does not support webhooks or push notifications. Ideal for scheduled or batch-oriented scenarios where real-time response is not critical. Common in legacy systems or when simplicity outweighs efficiency concerns. When should you choose a webhook trigger? Choose webhook triggers for real-time, event-driven integrations requiring immediate response. Best for high-volume or time-sensitive scenarios to minimize latency and execution costs. Preferred when the service supports subscription-based notifications. How do polling triggers impact performance and cost? Polling triggers can increase execution counts and costs due to frequent checks, especially with short intervals. They may lead to throttling if too aggressive, and consume more resources in consumption model. Longer intervals reduce overhead but introduce higher latency. How do webhook triggers impact performance and cost? Webhook triggers minimize unnecessary executions, lowering costs and improving efficiency. They provide near real-time processing with low latency. Require proper subscription management and error handling for unsubscribe. Provide an example of a common polling trigger. The recurrence trigger, built-in, runs workflows on a fixed schedule, such as every hour or daily. Used for batch processing, report generation, or periodic data polling. Supports simple intervals or advanced cron expressions with time zone awareness. Provide an example of a common webhook trigger. The request trigger, built-in, exposes an HTTP endpoint that others can call to start the workflow. Ideal for API-driven integrations or receiving webhooks from external services. Can include schema validation for incoming payloads. Name some built-in polling trigger examples. Recurrence trigger for scheduled executions. When a file is added or modified. Azure Blob Storage polling version. When a new email arrives. Office 365 Outlook polling. Name some built-in webhook trigger examples. HTTP request trigger for incoming HTTPS calls. HTTP webhook trigger for subscription-based push notifications. When a file is added. Azure Blob Storage webhook version, if available. Give examples of managed connector polling triggers. When a new email arrives. Office 365 Outlook. When an item is created. SharePoint or Dynamics 365. When a message is received in a queue. Azure Service Bus polling. Give examples of managed connector webhook triggers. When a new commit is pushed. GitHub webhook. When a payment is received. Stripe or PayPal webhooks. When an event occurs in Event Grid or Service Bus, push-based. How do polling and webhook triggers differ in consumption versus standard models? Both models support polling and webhook triggers. Standard workflows restrict some polling triggers in stateless mode and favor webhook for efficiency. Webhook triggers are recommended in high-throughput scenarios in both models. What happens when polling frequency is too high? High-frequency polling can lead to excessive executions, higher costs, and potential throttling. Azure may skip polls or return 429 errors if limits are exceeded. Best practice is to start with longer intervals and optimize as needed. How do you handle subscription management in webhook triggers? Webhook triggers automatically subscribe, unsubscribe when the workflow is enabled, disabled. Use the unsubscribe URL in the trigger definition to clean up on deletion. Manual validation may be required for custom webhook implementations. Explain the role of split-on with triggers. Split-on debatches arrays from trigger outputs, creating separate workflow instances per item. Improves parallelism for bulk events in both polling and webhook triggers. Commonly used with array-based triggers like new files or messages. What is the impact of trigger type on latency? Polling triggers introduce latency equal to the polling interval. Webhook triggers achieve near-instant activation upon event occurrence. Critical for time-sensitive applications like notifications or trading. Describe a scenario where switching from polling to webhook is beneficial. Replace polling for new file detection in blob storage with webhook if supported. Reduces cost and latency for event-driven file processing workflows. Improves scalability in high-volume storage scenarios. How do recent advancements, as of January 2026, affect triggers? Enhanced support for efficient change detection in polling scenarios using native JSON functions. Improved webhook integration with AI agent orchestration and MCP servers. Better handling of long polling in service bus triggers for sub-30-second intervals. What best practices apply to choosing trigger types? Prefer webhook for real-time needs and efficiency. Use polling only when webhook is unavailable. Monitor execution metrics to optimize polling intervals. How do triggers handle errors and retries? Polling triggers can configure retry policies for transient failures. Webhook triggers rely on the source service's retry mechanism. Failed triggers appear in run history for analysis. Explain concurrency control with triggers. Concurrency limits prevent too many parallel runs. Webhook triggers handle bursts better with proper limits. Polling can queue up if concurrency is restricted. Why understanding polling versus webhook is essential for interview and design. Demonstrates knowledge of performance, cost, and real-time architecture. Key for optimizing workflows in enterprise scenarios. Frequently asked in Azure certification and solution architect interviews. Thank you for watching this session on polling versus webhook triggers in Azure Logic Apps. If you found this video helpful, please like, share, and subscribe to ZoomInData. More Azure Logic Apps interview and tutorial videos coming soon. Stay connected and keep learning.